welcome back everyone. I'm sure you had a wonderful session with Matt. Matt has wonderfully shown how you can actually use reinforcement learning to train your robot, and it was really wonderful. I'm sure the students and professionals who are working with robotics, they found it very useful and interesting. Now we have with us Julie Elkins. So Julie is the training architect from AWS, and she is the training architect in A Cloud Guru. And she's going to talk about how you can get started with serverless. So I won't be taking any further time. I'd like to welcome Julie to take her session onwards. Hi, Julie.
Hi, thank you. Hi, everyone. Thank you so much for attending this session, Getting Started with Serverless. I want to cover what is serverless, what is Lambda, and how we can get started. So, my name is Julie Elkins, and I'm an AWS training architect at A Cloud Guru. And my focus has been more on AWS training. But the more I learn about serverless, the more there is to love and to get excited about. Serverless is really changing the way that we build our applications. And we use serverless at A Cloud Guru. We actually started as a totally serverless based platform. So let's go ahead and get started and let's talk about what is serverless. So AWS breaks serverless into four characteristics. First, there's no requirement for a host, so there are no servers to provision or manage. There's no overhead of patching or dealing with anything on a hosting operating system. Second, serverless needs to scale with our usage. So if we have requests come in, then the scaling needs to be automatic, and those requests can then be responded to. And third, we can tie in cost optimization here. So I'm really huge on making sure our AWS environment is cost optimized. And with serverless, we never pay for idle compute resources. This means that we can spin up resources as we need them. And because of this, serverless can help us save money. And in turn, it does not require us to worry about things like capacity planning, and we avoid problems like over and under provisioned resources. We basically pay for what we use. And then fourth, serverless can be highly available and fault tolerant. So as you may have heard, AWS has the AWS Global Network that is spread across regions. Regions contain multiple availability zones. And with Lambda and serverless, we don't have to worry about making it highly available. Okay, so what makes an application serverless? So typically, a serverless application will be made up of three parts. First, an event source, and simply put, events are things that trigger your functions to run. So an event could be a request to an endpoint, a change in your data state, or a change to your resource state. Then second, we have functions or function. And here we're talking about AWS Lambda. And then third is services, or what is Lambda talking to? So that service could be an API endpoint, a database, a data store, or maybe the function performs a calculation or action without needing to interact with that service. That's really common as well. So I've mentioned Lambda a few times. And for those not familiar with this service, you're probably wondering, what is Lambda? Well, Lambda is a Lambda is a service that falls under the compute services that AWS offers. It allows us to run code without provisioning or managing servers to run our code on. So, in other words, it's a service that allows us to run our code in a serverless manner. So, let's talk about what is Lambda. Well, Lambda is a function as a service product. So Lambda runs functions. And functions are a small piece of code that's written in a language. So we could have Java, Go, PowerShell, Node.js, C Sharp, Python, Ruby. And functions can be ran using a runtime like Python, Java, Node.js, etc. And we are billed for the duration of the function's execution. So, as we've touched on, Lambda is an event driven service, but these events can also be scheduled or manual invocations. So, Lambda functions are invoked on an event occurring. We develop our code in a language, we pick a runtime using that language, and then we can execute the code based on the triggering of an event. And Lambda is a compute service like EC2, but again, we're only billed for the time and the resources used to execute our function. There's no There's no overhead charge to use Lambda on top of what we're charged to execute our code. And with the AWS free tier, we get 1 million free requests per month, and our functions can run once, twice, or even multiple times. And we can even have multiple functions running at the same time. But Lambda functions do have a 15-minute execution limit. They cannot run longer than 15 minutes. And if they do, they're going to be terminated by AWS. So if we need to run longer than 15 minutes, we can use step functions, which we're going to be covering in a few minutes. So Lambda is considered to be serverless, but under the hood, there are servers. Every runtime environment is completely new, so there's no persistence. But Lambda is a great compute alternative for serverless architectures. And again, it's important to remember that Lambda functions are not persistent. So you do get that new runtime environment each time you invoke your function. And because of this, you may need to pull data into your runtime environment. And then if your function produces any outputs, you could store those in DynamoDB or an S3 bucket. And again, if we need longer execution times, then step functions are a great choice and they enable us to have functions run in steps, one after the other. So, what do you think are some use cases for Lambda and serverless? Well, Lambda can help with almost anything and everything. In fact, a cloud guru's entire platform at one stage was able to boast that we were entirely serverless. One use case, and probably the most popular these days, is data processing. And we can also use Lambda for real time analysis, map reduce, batch jobs. And there is a lot of big data ingesting and data processing that can actually happen in Lambda. It's really quite powerful. It's a great tool for data management. A second use case could be for web applications. And we see a lot of companies and people are using static websites, and they use Lambda and API Gateway on the back end to drive a lot of the dynamic elements of their web application. And we're going to be talking about API Gateway in a few minutes also. A third use case is when we ask Alexa to do something. That ask is usually ran on a Lambda function. And if you're interested in Alexa, we have a really great course that you can check out. And then, fourth, another big use case is automation. We can use Lambda to remediate security vulnerabilities and then set up automatic alerts. And also remediation using Lambda. And for our use cases with Lambda, we can have both synchronous and asynchronous execution models. So with Lambda, there are three types of execution models on how we can invoke our Lambda functions. Up first, we have synchronous. An example here is using API Gateway. So the way that that works is that a request comes into API Gateway, and then API Gateway will then invoke our Lambda function from that request, and then take the response of the Lambda function and reply back to the user making the request. And this is used with our web application or mobile application use cases that we just mentioned. But we also have asynchronous execution models, and this one works a little bit differently. So, with asynchronous execution models, we could have an SNS topic and we could send in a message to that SNS topic whenever an object is put into an S3 bucket. And then S3 is going to pass that information. So, we're passing where we stored that object in S3, and that location gets passed into the Lambda function. And once Lambda receives the passed information, then the Lambda function could work with Elastic Transcoder to make thumbnails. And when we invoke a function asynchronously, we're not waiting for a response from our function code like we would when we use a synchronous execution model. We're simply handing the event off to Lambda, and then Lambda handles the rest. But we also have a stream-based execution model, and we can use this with Kinesis or DynamoDB as an example. And the way that this model works is that Lambda can be polling these AWS services for information to pull off. So maybe with Kinesis, we are collecting IoT sensor data into Kinesis, and then our Kinesis shards can invoke Lambda functions against that and pull records in and then process those records. And an example with DynamoDB could be that we are using triggers. So as our records are written to our database, Lambda functions could be invoked for processing. Now, earlier we spoke about how a Lambda function can be triggered, and AWS has a lot of services that can serve as a Lambda trigger. Because we have all of these potential triggers available to us, there are so many different use cases where we could invoke Lambda functions. And serverless is getting a lot of press. It's really growing and it's getting really huge in the community. Over the last few years, we've seen a move towards microservices, and then microservices have become more event based. And that changes the way applications are built, along with the logic and the workflow for our applications. And the movement seems to be continuing and actually driving towards containers versus our execution environments. So, for a container environment, let's say like with ECS Fargate, we cannot trigger functions off of an event. So, it's not quite event driven yet as a Lambda function, but people are starting to build their own execution environments to deal with more dependencies and to get the needed control over their environments. And I think going forward, we're going to see a lot more control that's going to be given to developers, especially over their execution environments. So let's continue on and let's take a deeper dive and let's talk about using Lambda. So, the big part of Lambda is that we bring our own code and our own libraries too. We can also select the amount of memory that is needed. And when we choose our memory, we get an appropriate amount of CPU and network to go along with that memory choice. So, for example, if we chose 3 GB for memory, we would get we would get 2 CPU cores behind the scenes. And Lambda is also secure. We can securely grant access to our resources and our VPCs, and we can control who can invoke a Lambda function, and then also, of course, what that function can do once it's invoked. And to go along with security, AWS has made monitoring and logging of Lambda straightforward. We have built in logs that are sent to CloudWatch logs, and then CloudWatch metrics are available too for metric requests, errors, throttles, etc. And again, Lambda is stateless. So if you need persistent storage, we're going to have to use an external storage. And as we mentioned earlier, we can use our own code for our Lambda functions, but we can also put it in a zip file and upload it directly to Lambda. So we talked about security permissions. So we talked about security and permissions, and we mentioned earlier that we have control over where Lambda sits in our VPC, but we also have execution and function policies too. So we need to be able to give our Lambda functions the permissions via IAM roles that it needs to work with other AWS services like S3 or DynamoDB. But we also need to be able to control who can invoke the Lambda function. And here specifically, we could add a function policy to allow only API Gateway to invoke our Lambda function, or maybe just Kinesis can invoke it, or maybe even just S3. And the benefit here is that we don't have to add in authentication and authorization between their services because it's already part of the policy. Okay, so we covered Lambda at a very high level. Let's switch services and let's talk about another AWS service that is considered serverless, and that's API Gateway. So let's start off with what is an API. Well, an API is an application programming interface. It's a way that we can take our application that we created and provide its functionality to users or to other applications. It's a way for our applications and our app servers to communicate. So if we look at this diagram of APIs, on the left, we have services. So we could have EC2 instances, RDS database, Route 53, S3, and then on the right, we have ways to access AWS. So that could be an application that uses AWS services, the AWS CLI, or the user interface. And when we access AWS, we are actually using endpoints to connect to AWS. And you can see specific endpoints below. So each AWS service has its own endpoints in each AWS region. And these endpoints are entry points to our AWS APIs. So, for example, when we access S3, we are doing so through the API. And these APIs will also perform authentication, usually with usernames and passwords, but it can also be key based as well. And once we authenticate, then we are authorized to perform stuff. So remember that each time we interact with AWS, we have to verify who we are and what we're allowed to do. So, what value do you think API Gateway brings? Well, APIs need to be managed, and you have to manage the code, the hosting, and it's really a lot of admin overhead, especially if you want to make it scalable and highly available. So, AWS provides API gateways that are a managed AWS service and provides managed APN and provides managed API endpoints for us. So we don't have that admin overhead. And with API Gateway, we can create, publish, monitor, and secure our APIs. And this is really great for our serverless architectures because it's delivered to us as a service. And API gateways are built based on the number of API calls, the data transferred, and any additional performance features that we add. API gateways can also work with different architectures too. It can work with legacy designs, monolithic architectures, microservices, and also serverless architectures. And it's a great to add, and API gateways are great to add in front of our APIs. API gateways can also authenticate and cache for us as adding DDoS protection. So, API Gateway really provides a unified API interface across all of our APIs. Now, another similar serverless product that AWS has is Step Functions. And Step Functions is a serverless workflow management service, and it was designed to help out Lambda. So remember that Lambda's execution has a 15-minute limit. And AWS saw that a lot of customers were having their Lambda functions invoke other Lambda functions or daisy chaining their functions, and they were really spending a lot of extra time adding workflow code into their functions. So Step Functions was designed to help you so Step Functions was designed to allow you to pass that workflow from Lambda up to Step Functions. And we can set up the layout for our workflow. So there's a start with choices and states, and Step Functions can also retry. And Step Functions, again, can run much longer than a single Lambda execution. They can actually run up to 1 year. So, all of this serverless service sounds great, right? And it's really a very high level overview. And if you're interested in taking deeper dives, definitely please reach out to me. But you may be wondering, if you're not using Lambda, how do you get started using it? Well, you can jump into the AWS Management Console and get started, but you can also check out frameworks that AWS provides. So, AWS provides open source projects, and some of the framework examples you may see are for deploying projects to Lambda and API Gateway, but there are also some to help you deploy and manage your application, and also some frameworks that are specific to workloads. And the frameworks provide and include the needed IAM permissions. But AWS also provides the Serverless Application Model, also known as SAM. And this is an extension on top of CloudFormation that really streamlines what we need to build for our serverless applications. And the difference between frameworks and SAM is that SAM gives us fine grained control over how we configure our resources without impacting our code, versus frameworks that are more about how our applications run. So let's wrap this up and let's cover cost optimization, because cost optimization is important and it's something that I'm really, really passionate about. So when we only pay for resources when we use them, this helps us save money and cost optimize our workloads in our applications. And remember, we said earlier that we never pay for idle Lambda service because Lambda doesn't sit idle. And AWS bills us in 100s of milliseconds. And AWS has said that the reason they choose that particular pricing model is because API requests are usually in the 100s of milliseconds. And they really try to align the pricing models with that small function based applications that we're trying to build. We do not pay for hourly, daily, or monthly minimums, and no per device fees. And like AWS says, we simply never pay for idle. So that's a really high level overview of serverless, Lambda, API gateway, and step functions. But we also talked about how we can get started. Again, if you're interested in taking a deeper dive into anything we talked about today, please do let me know. We have some really great courses at A Cloud Guru covering essentials, covering deep dives, but also certification exam prep courses as well. Thank you so much for attending this session with me. Please let me know if you have any questions and please feel free to reach out anytime. It was really great to be here with y'all today.
Thank you, Julie. It was really very wonderful, a very high level, serverless session by you. So there are a few questions that I see in the panel. So someone has asked that what are the AWS serverless application during COVID-19? What are the use cases? Can you give an example? What are the industries they're going with
Could you repeat
serverless?
that question one more time? You broke up a little
So
bit.
yeah, sorry. So the question was, what are the AWS services application during COVID? Serverless applications.
Let me just pull up the questions.
Okay. Okay.
Well, what are the AWS serverless applications during COVID?
Example of applications during COVID. I think by which he mentioned or she mentioned.
I think for as far as COVID hasn't really changed serverless that much, so it would still be the same. Mostly, I would say probably the biggest one is probably web applications. I think because more people are online, they're shopping online versus going into the stores.
Someone asked, is serverless really serverless?
No, I mean there's definitely servers in the background. The reason they say it's serverless is just because if you're using serverless, you're not actually managing the host, or the EC2 instances. So it just makes it a little bit easier to manage. But yes, there are definitely servers in the background.
Mr. Ashraf Bhuya asked when we should use Lambda at our production level. Should we use Lambda only for microservices?
Well, I think that's really going to depend on, your environment and definitely your production level. If you're using EC2 versus Lambda, I think I think you could definitely try out using Lambda because with your EC2 instance, you're paying for that usage 24 hours a day for however much you're using it. But with Lambda, you only are paying for it when you invoke the function and basically for your function's execution and the resources that are used during that execution. And you have to also consider the AWS free tier. So you get 1 million free requests. That's a lot of free requests. So you could see some cost savings there.
Yeah. Yeah, serverless is actually like that. It actually optimizes costs 10 times. That's what I have seen. So Mr. Ashik Ahmed Khair, he asked that can we think of Lambda as an enumeration for serverless service stack?
Um, I probably that one I'm not really sure about. I'd have to definitely look into it a little bit more. So I just am getting into serverless myself. I've been studying it the past few months, but I could definitely check that out and get back to you.
Absolutely. One last question that can you do a comprehensive comparison between AWS Lambda and Amazon EC2? So what are the differences or advantages of each of the items?
So they're both compute services. EC2 instances are basically your own individual server. It's a virtual machine, where Lambda is a serverless. So it still uses that, but you're not paying for the entire instance. So that's the big difference. There's servers in the background. So serverless or Lambda uses EC2 instances in the background, but you're not paying for that EC2 instance usage.
Yeah. So I have a personal question to you, Julie, since you mentioned that you you very recent time started looking into serverless. So what is basically your key inspiration to move into serverless learning?
Oh, I'm fascinated by AWS, but I've been joining different YouTube videos, and I would really like to get more into machine learning and to start building. So that's kind of how I jumped into serverless. So I think, it's a big leap. And so you have to have you have to put your foot in every little bit of pool so that you have information about everything. So what I'm trying to do is get that solid base understanding of serverless, and then just to continue on. So I'm looking for a specialty. So I have a very wide overview of AWS, but I'm looking for something that I can just really get my teeth into and just really love. And serverless seems to be that. There's just so many options. There's so many different things you can do. So yeah, I've had a really great time lately.
Wonderful, wonderful. Thank you so much, Julie. Thank you for your time, and we really appreciate that you take part in the first ever AWS Community Day in Bangladesh. This is our first time, and you said that you were nervous. I think you did a splendid job, and
Oh, thank
I
you so
thank
much.
you once again for your
Thank you.
session.
I'm so
Thank you
happy
so
to be
much.
here with y'all today.